can solve real-world problems using systems of linear equations. Let's read together. 1, 2, 3. I can solve real-world problems using systems of linear equations. So, we don't need a Fermat model because we already know what systems of linear equations are. What are they? Well, systems of linear equations, we said they are, they are a set of 2 or more linear equations with the same variables. I gave you examples, non-examples, and I gave you steps. Remember that? So we don't need steps. We don't need the Fermat model because we already have all that. Today's going to be the day that we apply it to word problems. But before that, copy this home plate, please. Example Q says, with a tailwind, an airplane makes a 600-mile trip in 2 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is the plane's speed? What is the wind speed? Also, you're going to work on page 309. Copy that, please. So, that's your home plate for tonight. Here we go. Let's get started. So, like I said, we already have steps, but look up. Today, we're going to focus on this problem-solving strategy. Look up, please. Read the problem at least twice and underline key information. Have we been doing that with regular word problems? Yes. Have we been building tables and choosing variables for our tables? Yes. Have we been rereading and writing expressions, equations to represent those relations from the problem? Yes. Have we been solving equations and finding the unknown? Yes, and we checked our solutions, right? So today we're going to continue using this. The other one is over here. It's a poster that I mentioned some time back. It's called Cubed. It's another strategy where you circle important numbers, underline questions, box keyword phrases, eliminate information not needed, or draw pictures and graph at the end. So that's why it's called Cubed. Is your paper cubed? So if you follow those steps, that also works. So to get us started, we're going to start with a word problem, and it says, example 1. Mia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. How many sheets of each can Mia buy? Now, one thing I want to bring to your attention, look up please, is the fact that here, now we no longer only have items like we did the other day where I asked you, how many items are they talking about? 2. How many car rental places? 2, and so on and so forth. Here, we have one person. She's buying 2 different things, and not only that, now we're dealing with costs of those things. You guys see the difference now? Okay, when you get to these kind of problems that involve a lot of items, then we're going to need a different table. Now, I'll show you that table in a bit. Copy this problem really quick. Yeah, 1 minute. Go. So lesson is going to be about word problems? Okay, word problems only? Thank you. Oh, my God. Can you read it for us? All right, it says, Mia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. How many sheets of each can Mia buy? So step 1 for our problem-solving strategy is to read it twice, at least twice, and underline key information. The very first thing I see here that I need to underline is the money. She has $7.75, and the felt sheet costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. Okay? Next, the other type of information, I'm going to switch to blue now, that I'm going to underline, is what else are they talking about? They're talking about the different sheets. How many total sheets does she need to buy? 12, so I underline 12. And what kind is she going to buy? Felt and cardstock. Okay? So now that we have our information underlined, the question here is how many sheets of each can Mia buy? So this is the table I want us to use for systems of equations. Everybody with me? For systems of equations, we're going to use this table. 3 lines down, 1, 2, 3, and 2 across. Okay? We've used something similar before. The only thing before we needed to wait and identify how many items or how many people that we're talking about in the problem. Remember that? So here, let's start with our information. What is the first thing we underline? $7.75. and we underline 50 and 75 cents. What could that be labeled in this row right here, in my first row? What could I label this row if I'm going to write all these amounts? Or costs. So let's write this as costs. Where do we usually put the total amount? At the end, so that goes right here, 7.75, and we're going to label this column total. So that means we have these two, and then what are the other amounts? We have 0.50 and 0.75. However, we have a dilemma. What does 0.50 stand for? Felt. So this column we're going to label felt. That means this column we're going to label cardstock. All right. So let's see. But still, we still don't have this clear here. It costs 50 cents for felt, but what if we didn't have it labeled there? What would we need here to identify that it's felt? Felt. F. Very good. Therefore, this one is 0.75 C. All right? Now that we have that, we're done with everything that we underline in red. Yes? Now let's go to the blue. What can we label the blue here for our row for blue? What is it? Amounts, close. Let's say in another problem they talk about different fruits. In another problem they talk about whatever. Objects, or let's call them items. So how many total items are they purchasing? 12. Do we know how many felt? No, so we're labeling this F. Do we know how many cardstock? No. And do you see the system already? Okay. Imagine that the table's not there. You only have the amount that you wrote in there. Do you guys see it? Okay, if you don't see it, let me write it out. Here we go. Our equation here is 0.50F. What else? Plus 0.75C equals 7.75. Therefore, my second equation is F plus C equals 12. Copy that, then we're going to solve it. All right, here we go. Focus, please. Look at this system. We already know 3 different ways of solving the system, right? And if you notice, it's in standard form. Do you guys notice that? So which method can we use? What is it? Elimination, okay. But one thing is that in order to eliminate either variable, they need to be the opposite coefficient, right? So which one would you like to eliminate, the F or the C? F, okay. So if we eliminate F, we need to multiply times negative 0.50, the entire equation. This becomes negative 0.50F, negative 0.50C equals negative 6. And now we can eliminate the variables. So 50 minus 50, they cancel. What is 0.75 minus 0.50? 0.25C equals 775 minus 6, that's 1.75, and it's solved. Divide by 0.25, divide by 0.25. C equals, let's see, 1.75 divided by 0.20. Move it over twice. It fits in there 7. 7 what? 7 what, guys? Card stock sheets. So, from there, You get the equation for the items. What was the equation for the items? F plus C equals 12. But now we know what C is. It's 7. If you do it in your noodle, right? But what did I ask you to do? But what do I ask you to do? Show me your work, right? Okay. Guys, focus, please. So we subtract 7, F equals 5, and what is that? Felt sheets. So what would be our statement here? Write it down, please. Mia would buy 5 felt sheets and 7 cardstock sheets. 10Q. And by the way, guys, if we were to write this as a solution, as a point, what is my coordinate? That is incorrect. If this is standard form, which one represents X? Therefore, this is 5, 7. Because you always go with the one on the left being X. It is. AX plus BY equals. Never mind. This is C as a constant, not C as a variable. All right. Let's recap. Look up. So once again, we read the problem at least twice. We underlined key information. From there, we build our table. With that information, we started labeling stuff with variables. From there, we got that. We wrote our equations, and we solved using elimination for one and then the other, and then we wrote our statement. We got it? Okay, let's go to number 2. Don't copy this problem. I want you to set up your table. It says, example 2, Chris spent $14.85 to buy 13 flowers. He bought lilies, which cost $1.25 each, and tulips, which cost $0.90 each. How many of each flower would Chris buy? Don't copy that. Go on and keep going. So here we go. I'm going to underline the key information. I want you to get your table ready and see if you can set it up. So key information here, I see that it's this plus this and this, okay? So this one belongs to the lilies. This one belongs to the tulips, all right? And then the second piece of information is here. And what kind? Once again, lilies and tulips, okay? So I'll give you some time to set up your table and see what you get. You don't have to solve it. I just want you to set up the table to see if you're going to be able to abstract the equations from there. Go. Okay, here it goes. I said for systems of equations, I said 3 lines down, 2 across. The first piece of information that I underlined was the costs. The total is $14.85. Then I have $1.25 and $0.90. So far, so good? And you wrote here total. The $1.25 corresponds to lilies. The $0.90 to tulips. Therefore, this is 1.25 L, and this is 0.90 T. So far, so good? And then here you wrote items. The total items are 13. We don't know how many lilies or how many tulips. Can you get the equations from there already? And you know what to do from there, yes? All right. So we're done with these kind of problems. These are item and cost type of problems. But look at this next one, which is part of your home play also. Example 3, copy this. With a tailwind, an airplane makes a 900-mile trip in 2.25 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is this plane speed and what is the wind speed? Copy that, and then we'll go over it. Go. As you're copying this, let me read it again. It says, with a tailwind, an airplane makes a 900-mile trip in 2.25 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is the plane speed? What is the wind speed? Now, as you're writing things down, I don't know if you noticed, this one doesn't have cost, and it doesn't have, like, different types of items, right? But it does talk about different things. What kind of things does it talk about? Time, what else? Speed, what else? Which is what? Distance. And that's why for this one, we're going to use something that you are already using in science, which is the rate times time equals distance formula. Remember that? Right? That's why this is considered, so label this one a rate problem. Rate problem. So when you get to systems of equations that involve rates, the process goes as follows. Once again, same table, 3 lines down, 1, 2, 3, 2 across. And let's underline key information. The first thing that comes to mind to me is this word, tailwind. Okay, tailwind. And the plane makes that a 900-mile trip, and the time is in 2.25 hours. Okay, now with blue, I'm going to switch because the return trip is against the wind, makes the trip in 3 hours. And if it's a return trip, how many miles is that? 900. So you underline 900 again because we're going to use that information again. Does that make sense? All right, so let's start labeling this. So to start off, rate problems, we're going to write them like this. Rate times time equals distance. And now we know where things are going to start filling in. So I'm going to start with the first part. What was the first thing I underlined? Tailwind. That goes here. Tailwind. Let's go with the information that I have so far. What was the total mileage? And that goes right here, 900. What was the time? 2.25. This is where it gets a little interesting. So let me explain tailwind. Who's been out there when your teachers ask you to run the mile? Everyone, right? Well, what's that? No, I loved running when I was in school. You walk it. Anyways, and then who's been out there running when there's a lot of wind? What happens when the wind hits you on your back? Does it increase your rate or does it decrease? So for the rate here, you're going to put increase. It's increasing which rate? Which rate? Which rate? Okay, what are we talking about here? A plane, right? So it's increasing the plane's rate. What's increasing the plane's rate? The wind. So this is P plus W. Everybody with me? No. When you're running and it hits you on your back, that's why it's called tailwind, because the wind hits you on your tail. And it makes you go faster, right? That's the second part. So let's go to the second part. Against wind. So what goes here, guys, as the rate for against the wind? P minus W, and here it's 3 hours. And what's the distance? The same, 900. All right, I'm going to go to the right. Let me make some space here. Here we go. Do you see the equation forming now? Watch. It's P plus W, and instead of putting the multiplication sign, since it's a binomial, I'm going to put it in parentheses, 2.25, and that is equal to 900. Our second equation, I want you to leave, by the way, look up, leave a little bit of space here underneath here because we're going to do something really quick. And let's write our second equation. P minus W times 3 equals 900. Are we there so far? So watch. In order to set them in standard form and start our solving systems, we can either distribute, or what else can we do to get rid of this 2.25? Divide. So we divide by 2.25 each side, 2.25. So we're left, on this side we have P plus W equals 900 divided by 2.25. To save us time in our long division, that is 400. Same thing with this one. To get rid of this 3, we divide by 3. We're left with P minus W equals, what do you notice? What do you guys see with these two? Elimination, right? So therefore we eliminate the W's. We're left with 2P equals 700. Divide by 2. P equals 350 what? Tell your neighbor. 350, which is miles per hour. So, Sergio, which one of these two equations shall we use to substitute this value and find the wind speed? P plus W equals 400. So therefore this is 350 plus W equals 400 minus 350. W equals 50 miles per hour. And you know how to write your statement, right? The plane speed is 350 miles per hour. The wind speed, 50 miles per hour. All right. So once again, your home plate was that word problem and page 309. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.